I'm a little worried about putting the wood any further down because in case there's eyes.
Something unusual is happening in Canada. In just the last few months, scientists have uncovered ancient settlements, rare minerals, and geological surprises that no one predicted. These discoveries are changing how we understand Canada's past and what its future might hold. 1. Ancient lakebed found beneath prairie farmland. Earlier this year, soil researchers surveying farmland in southern Manitoba stumbled on something unexpected. Using ground-penetrating radar and electromagnetic soil conductivity scans, they discovered a large circular depression roughly 8 kilometers wide, buried beneath what is now wheat fields. What looked like subtle variations in crop growth turned out to mark the outline of a dried ancient lakebed, possibly dating back over 10,000 years. What makes this site particularly interesting isn't just its age or shape, but the unusual mineral deposits locked in its lower layers. Core samples pulled from the area show an unusual concentration of fine clay particles and trace metals, suggesting hydrothermal activity may once have occurred at the bottom of the lake. Even more curious, the presence of tiny fossilized diatoms that aren't typically found in inland freshwater environments. Researchers at the University of Manitoba believe the lake may have briefly connected to a much larger glacial meltwater system, or even been part of an ancient inland sea that spanned the prairie provinces. Further analysis is underway, but early data hints this lake could help fill gaps in our understanding of how Canada's interior landscape shifted after the last ice age. If confirmed, it could push back the timeline for post-glacial colonization by both plants and early human communities in the region. Second submerged Ice Age landscape found off Newfoundland's coast. Marine geologists mapping the continental shelf off Newfoundland recently made a discovery that could change our understanding of early human migration across North America. Using high-resolution sonar and sediment core sampling, researchers identified the faint outlines of an ancient river-valley system submerged beneath 90 meters of water, likely flooded during the rapid sea level rise at the end of the last ice age. The find includes old stream beds, oxbow channels, and what appears to be a low-lying delta, features that could only have formed when this area was dry land. Based on sediment dating, the valley likely last saw the open air around 12,000 years ago, during a period when glaciers were retreating and global sea levels were still rising. But the real excitement started when divers recovered fragments of worked stone embedded in the valley's banks. The tools, simple flake cores and blades, show signs of deliberate shaping, sparking speculation that early human groups might have used this landscape as a seasonal migration route or even a temporary settlement area. If confirmed, this would represent one of the earliest known offshore archaeological sites in eastern Canada, and suggest that early inhabitants of North America may have followed now submerged coastal corridors long before inland regions became habitable. The discovery also raises questions about how much of Canada's prehistoric record is still hidden underwater. During the Ice Age, large parts of what is now seafloor were dry plains, river valleys, and coastlines that supported plant and animal life. When glaciers melted and the oceans rose, sometimes several meters per century, entire landscapes were lost beneath the sea. To get a clearer picture, scientists from Memorial University and the Geological Survey of Canada are expanding their surveys across the Grand Banks and the Laurentian Channel. They're combining sonar scans, ocean bottom cores, and AI-driven seabed analysis to locate other features buried under marine sediment. The implications go beyond archaeology. Understanding how sea levels changed in this region over thousands of years helps refine climate models and predictions for future coastal erosion and sea level rise. It could also help identify ancient freshwater reserves or habitats that today influence marine ecosystems. What began as a routine geological mapping mission has opened a window into a forgotten world, one that once connected people, wildlife, and land, now hidden beneath the waves. 3. Rare deep earth mineral found near Yellowknife surprises geologists. In early 2025, a team of geologists conducting a mining survey just outside Yellowknife, Northwest Territories, encountered something they hadn't expected. a cluster of crystals containing a mineral rarely seen outside deep mantle rock, wadsleyite. Normally stable only under extreme pressure more than 400 kilometers beneath the Earth's surface, this discovery has sparked new questions about the geological history of Canada's north. The mineral was found embedded in a type of volcanic rock known as kimberlite, which is already known for bringing deep earth materials to the surface, including diamonds. But wadsleyite is different. It only forms under immense pressure and contains water locked in its crystal structure, leading researchers to consider whether the region may have experienced a unique tectonic or impact event in the distant past. Researchers at the University of Alberta analyzed the crystals using Raman spectroscopy and confirmed the mineral's identity. Preliminary estimates suggest the wadsleyite samples may be more than 1 billion years old, likely pushed to the surface by a powerful volcanic event long before the continent settled into their modern positions. What makes this find particularly important is its potential to reveal how water moves through Earth's mantle. Wadsleyite can hold up to 3% of its weight in water, not as liquid, but as hydroxide ions within its structure. This discovery supports the growing theory that large amounts of water may be stored deep within the planet, influencing everything from plate tectonics to volcanic activity. Some researchers now wonder whether other deep mantle materials might be hidden in Canada's vast shield regions, especially in areas shaped by ancient cratons, stable pieces of continental crust dating back billions of years. The Slave Craton, where this discovery occurred, is one such zone, and geologists believe it may contain some of the oldest rocks on Earth. Beyond its scientific implications, the find has also caught the attention of the mining industry. Wadsleyite itself isn't economically valuable, but the conditions that produce it, high-pressure systems, and mantle-derived rocks, can also be associated with valuable minerals like diamonds and rare earth elements. Follow-up drilling is already underway, not just to study the rock composition, but to search for deeper deposits and trace the origins of this unusual mineral signature. What started as a resource exploration project has quickly turned into a major geological puzzle, one that may offer rare insights into Earth's inner workings, hidden just beneath Canada's northern terrain. Fourth, fossilized tropical forest discovered beneath Alberta coal seam. In southern Alberta, researchers excavating a long-dormant coal mine near Drumheller made an unexpected find: the remnants of a fossilized tropical forest buried beneath a layer of ancient coal. While the area is already known for its rich dinosaur fossils, this particular discovery has opened up a new chapter in Canada's prehistoric story, one that dates back nearly 60 million years. What makes this site remarkable is the level of preservation. Petrified tree trunks, fossilized palm fronds, and even impressions of vines and broadleaf plants have been found lying in place, suggesting that the forest may have been rapidly buried in volcanic ash or sediment from a flash flood event. This type of preservation is extremely rare in northern latitudes, where climate extremes usually destroy delicate organic structures over time. Researchers from the Royal Tyrrell Museum and the University of Alberta have been analyzing the site for several months. Carbon isotope testing, pollen analysis, and stratigraphic dating confirm that the forest likely thrived during the Paleocene-Eocene thermal maximum, a period when global temperatures spiked and lush tropical ecosystems extended far into what is now temperate or even subarctic zones. This fossil forest suggests that what is today dry prairie was once a dense, humid ecosystem teeming with plant and insect life. Preliminary findings include several extinct plant species, including a now-vanished type of flowering magnolia and a towering relative of modern tree ferns. Insect impressions found in the silt layers include dragonflies, beetles, and an unusually large ant species with wingspans over 3 inches wide. But it's not just about what lived there, it's about what this says for today. The discovery is giving scientists new insights into how ecosystems adapt or collapse during periods of extreme climate change. By studying growth rings, leaf chemistry, and soil layers, the team is building models to understand how rapid warming affected plant cycles, water availability, and biodiversity. There are also potential implications for carbon science. The coal seam that overlaid the forest was formed from compressed plant material over millions of years. Studying the transition from living forest to coal deposit may offer new understanding into long-term carbon sequestration in natural environments. The team is now working to preserve key sections of the forest in situ while continuing analysis of the surrounding geological layers. Plans are underway to make the site partially accessible to the public through an educational exhibit that will showcase Alberta's ancient tropical past. This discovery isn't just a glimpse into an ancient forest, it's a window into Earth's climatic extremes, and a warning about how quickly ecosystems can transform. 5. Surge in Arctic shark sightings raises new ecological questions. In 2025, marine biologists monitoring the eastern Canadian Arctic reported a surprising trend: a sharp increase in sightings of Greenland sharks in regions where they were once rare, including Hudson Bay and the waters north of Labrador. These slow-moving, long-lived creatures, sometimes nicknamed sleeper sharks, typically inhabit deep, cold ocean basins. But researchers now believe they may be adjusting their patterns due to rising ocean temperatures and shifting prey availability. Greenland sharks are among the most mysterious animals in the ocean. They can live well over 250 years, grow to over 6 meters long, and spend much of their lives in frigid depths where little light penetrates. Historically, they've been found in the deeper waters around Baffin Bay, Davis Strait, and parts of the North Atlantic. But over the past year, researchers with Fisheries and Oceans Canada have documented dozens of sightings, some in surprisingly shallow waters. Using satellite tags and deep-sea sensors, scientists have tracked individuals moving farther south and into areas with thinning sea ice. Some have been spotted just 100 kilometers from communities along the Nunavut coastline, closer to shore than ever before. What's driving this shift is still being studied, but several factors are likely in play. First, the Arctic is warming at nearly 4 times the global average. As sea ice recedes and water temperatures rise, deep ocean currents that once acted as cold boundaries may be weakening, allowing species like the Greenland shark to expand their range. Second, prey distribution is changing. Capelin, Arctic cod, and other cold water fish have begun to migrate or decline in some areas, pushing predators to follow. Third, less ice means more light penetration and slightly warmer conditions in the mid-depths, which may make historically inhospitable areas more accessible for these deep-sea giants. While the sharks are not considered dangerous to humans, their increased presence in shallower waters raises concerns about ecosystem disruption. Greenland sharks are apex scavengers and can impact the balance of local food chains if their numbers continue to grow in new areas. The sightings also offer a rare scientific opportunity. Because Greenland sharks are difficult to study due to their deep habitat and slow metabolism, these closer encounters allow for better sampling, genetic analysis, and even insights into Arctic ecosystem health. Some individuals tagged this year will be tracked over the next decade to better understand their range and reproductive behavior. As climate change continues to reshape the Arctic, these slow-moving giants may be just one example of species adjusting in ways scientists are only beginning to understand. 6. Hidden aquifer collapse, detected beneath southern Ontario. In mid-2025, hydrologists studying groundwater levels across southern Ontario made a discovery that's raising alarms in both scientific and municipal planning circles. An ancient underground aquifer system, once believed to be stable, appears to be collapsing in key sections. The changes were detected through a combination of satellite-based land deformation mapping and pressure sensor data from deep monitoring wells near the cities of Guelph, Hamilton, and London. What makes this finding significant is not just the loss of a water source, it's what the collapse signals about the subsurface environment. These aquifers have supported farming, industry, and residential water needs for decades. But new research indicates that parts of the bedrock and glacial till, layers that once held groundwater in place, are beginning to compact and fracture, leading to subsidence and, in some areas, irreversible loss of storage capacity. The discovery began with irregularities in well pressure readings. Over several months, some wells showed abrupt drops in water level, despite no significant increase in withdrawal. At first, this was assumed to be sensor malfunction, but cross-checking with satellite radar data revealed localized surface sinking in areas that matched the well locations by just a few centimeters, but enough to confirm ground movement. Geological surveys suggest this may be a result of over-extraction, compounded by climate variability. Ontario's southern region has experienced more frequent drought-like conditions over the past 5 years, causing municipalities and agricultural users to rely more heavily on groundwater. As aquifer pressure drops and the water is removed faster than it can be naturally replenished, fine sediments and voids within the aquifer begin to compact, permanently reducing the space available to store water. This process, known as aquifer consolidation, has long been documented in parts of California and Asia. But until now, it wasn't considered a serious risk in Ontario. The fact that it's now appearing in one of Canada's most densely populated and agriculturally productive regions has serious implications. Aside from water scarcity concerns, the collapsing aquifer zones may also threaten building foundations, roads, and underground infrastructure. Local municipalities are now reassessing zoning regulations and considering limits on new well permits in affected areas. In response, the Ontario Geological Survey and Environment Canada are launching a joint initiative to map vulnerable aquifers using ground-based LiDAR and remote sensing technologies. They aim to identify which regions are most at risk and explore strategies for artificial recharge and groundwater conservation. This discovery highlights the need to rethink how Canada manages its hidden water reserves, especially as demand grows and climate patterns shift in unpredictable ways. 7. Permafrost thaw reveals prehistoric animal remains in Yukon. In the summer of 2025, unusually warm temperatures in Yukon's Klondike region exposed a new layer of permafrost melt, and with it, a nearly complete mummified carcass of an extinct steppe bison. The discovery was made by placer miners near Dawson City, who reported the unusual find to nearby researchers affiliated with the Yukon Paleontology Program. Within days, a scientific team was on site, recovering not only the bison remains, but fragments of ancient grasslands, insect life, and preserved soil microbes. While frozen fossils are not unheard of in this part of Canada, the level of preservation in this case is exceptional. The specimen still had intact skin, muscle tissue, and even remnants of stomach contents, offering a rare glimpse into what the Ice Age environment of Yukon looked like roughly 9,000 to 10,000 years ago. As the team carefully excavated the site, they uncovered additional organic material, including small rodent bones, a cluster of beetle casings, and layers of peat embedded with preserved plant roots. These biological archives are now being analyzed to reconstruct the late Pleistocene ecology of the region, data that could help explain how species adapted, or failed to adapt, to a warming post-glacial world. Beyond the scientific curiosity, this discovery is part of a much larger trend. Satellite monitoring and ground-based measurements have confirmed that permafrost across the Yukon and Northwest Territories is thawing faster than previously projected. In some areas, the thaw depth has increased by more than 50% over the past 2 decades, destabilizing roads, buildings, and even archaeological sites. The exposure of ancient remains is becoming more common as the frozen ground recedes. In 2023 and 2024, similar discoveries included a juvenile woolly mammoth foot and a section of preserved antelope horn. Each find adds to a growing database of Canada's prehistoric biodiversity, but also highlights the ecological and infrastructural consequences of rapid thaw. Researchers are now collaborating with Indigenous communities, many of whom have ancestral knowledge of these landscapes. Elders from the Trondek-Wet'suwet'en First Nation have contributed stories about unusual bones found in riverbanks long before scientists arrived, offering context and cultural depth to modern-day discoveries. With more thaw expected in the coming years, Canada's north is becoming both a rich paleontological resource and a climate warning system. What lies beneath the melting permafrost isn't just the past. It's a reflection of what's coming next if warming continues unchecked. 8. Canada's first commercial-scale geothermal plant launches in Alberta. In a major milestone for renewable energy in Canada, the country's first commercial-scale geothermal power facility officially came online in early 2025 near the town of Rocky Mountain House, Alberta. The project, known as the Borderlands Geothermal Station, is a 5-megawatt facility capable of powering over 7,000 homes using heat drawn directly from the Earth's interior. While geothermal energy has been explored in Canada for decades, this marks the first time it's been successfully implemented at scale. What makes this development noteworthy is both its location and timing. Alberta is best known for oil and gas, but it also sits above deep sedimentary basins, ideal for geothermal development. As traditional energy markets shift and carbon reduction goals tighten, projects like this are positioning Alberta to diversify its economy without abandoning its deep expertise in subsurface engineering. The Borderlands facility taps into geothermal reservoirs more than 3,500 meters below the surface. Using a pair of production and reinjection wells, hot brine is pumped up, passed through heat exchangers, and then returned underground in a closed-loop system. This produces reliable baseload electricity with virtually zero emissions, no combustion, and a minimal land footprint. The project is a joint effort between a Canadian clean tech firm and Indigenous business partners from the Nakota and Cree nations, who see geothermal not just as a green energy opportunity, but as a tool for long-term energy sovereignty. Local community involvement was built into the project from the ground up, including training programs, equity partnerships, and resource stewardship agreements. Beyond its environmental benefits, the project also leverages Alberta's existing workforce. Drillers and engineers previously employed in oil exploration have seamlessly transitioned into geothermal roles, highlighting how the energy transition doesn't necessarily mean abandoning expertise, but rather adapting it. Geothermal energy is also highly scalable. In fact, follow-up surveys have already identified multiple hotspots in southern and central Alberta with similar thermal gradients. Plans are underway for a second facility near Lethbridge, and feasibility studies are being considered for parts of Saskatchewan and British Columbia. Despite Canada's immense geothermal potential, the country has historically lagged behind others like Iceland or the US in harnessing it. The success of the Borderlands plant could signal a shift, not only for Alberta, but for national energy policy. It demonstrates that geothermal is not only technically feasible, it can be economically viable and socially inclusive, as energy demand grows and pressure mounts to decarbonize. Tapping the heat beneath Canada's surface may finally be gaining momentum. 9. Canadian satellites detect unusual methane leaks from boreal forests. In spring 2025, researchers from the Canadian Space Agency and Environment and Climate Change Canada announced a puzzling new finding. Satellites equipped with hyperspectral sensors detected irregular spikes in methane emissions across parts of Canada's boreal forest, particularly in remote areas of northern Manitoba and eastern Saskatchewan. While methane is often associated with agriculture, fossil fuels, or wetlands, the patterns captured by satellites did not match known human or natural sources. These emissions, detected over the course of several months, appeared in short bursts and came from ground areas previously considered low risk for methane release. Initially thought to be instrumentation errors, the anomalies were confirmed by cross-referencing data from multiple satellites, including Canada's GHGSat constellation and European partners. Field investigations are now underway, and early theories suggest a combination of factors could be involved. One hypothesis points to thawing patches of permafrost hidden beneath forest soil layers. As these previously frozen areas warm, they may be releasing trapped methane from ancient organic material, something scientists call thermokarst methane. Another possible cause is microbial. When soil conditions shift, particularly with more moisture and heat, certain microbial communities begin breaking down organic matter in ways that emit methane. These microbial hotspots might be forming in response to increasingly unpredictable climate patterns, including intense rainfall and longer warm seasons. If confirmed, this would mark a new class of emission source, one not fully accounted for in current climate models. The boreal forest, which stretches across more than half of Canada's landmass, has traditionally been viewed as a major carbon sink, a region that absorbs more greenhouse gases than it emits. But these new findings suggest that under certain conditions, parts of the forest may shift from sink to source. The implications are serious. Methane is a greenhouse gas more than 80 times more potent than carbon dioxide over a 20-year timescale. If forest soils begin releasing methane at scale, it could create a feedback loop that accelerates warming across the Canadian North. To better understand what's happening, researchers are deploying mobile labs, drones, and soil monitoring equipment at several key sites. The goal is to build a detailed map of methane flux and tie it to local environmental changes. This discovery underscores the value of space-based environmental surveillance and the need for real-time, ground truth data. It also reveals a more complex picture of the boreal landscape, where climate change is not just melting ice and shifting species ranges, but potentially awakening ancient gases long held underground. 10th breakthrough in quantum memory puts Canadian lab on the global map. In June 2025, researchers at the University of Waterloo's Institute for Quantum Computing, IQC, announced a significant leap forward in quantum memory technology. For the first time, scientists successfully demonstrated stable quantum data storage at room temperature using a synthetic, diamond-based processor. The experiment lasted only seconds, but those seconds could change everything. Quantum memory is a critical component in building functional quantum computers and secure quantum networks. Unlike traditional memory in classical computers, quantum memory must hold quantum states, such as superpositions or entanglement, without losing information to the surrounding environment. This has long been the bottleneck in scaling quantum systems beyond lab experiments. Until now, most quantum memory devices required ultra-cold environments, often near absolute zero, to prevent decoherence, a process that causes fragile quantum states to break down. But the IQC team used nitrogen vacancy, NV, centers and diamonds to trap and hold qubits in a stable configuration. What's new is how they did it, with enhanced control algorithms, improved material synthesis, and error correction methods that hadn't been combined before. The success didn't go unnoticed. Within weeks, international quantum research institutions and private sector leaders, from IBM to China's Quantum C-Tech, requested collaboration. For Canada, which has long been a quiet frontrunner in quantum research, this breakthrough affirms its global position in the quantum race. Why does it matter? Because whoever solves quantum memory first gets much closer to solving the whole system. Quantum memory is essential for developing quantum repeaters, devices that extend quantum communication over long distances, which are the backbone of unhackable internet infrastructure. It also plays a major role in quantum processors, where data needs to be stored reliably between operations. For now, the breakthrough remains a proof of concept, but the IQC team believes a commercial prototype could be viable within 3 to 5 years. They're already working with Canadian tech firms to explore applications from encrypted government communications to quantum-enhanced AI models. At the policy level, Canada's Natural Sciences and Engineering Research Council, NSERC, is investing more heavily in quantum talent development and international cooperation, hoping to retain leadership as quantum computing becomes a pillar of next-generation technology. Beyond the headlines, the achievement represents something deeper. That homegrown innovation, sustained by public research and university partnerships, can still make world-shifting advances. The fact that this happened not in Silicon Valley, but in Waterloo, Ontario, is a quiet but powerful reminder that Canada isn't just watching the future unfold, it's helping build it. What's emerging across Canada right now isn't just surprising, it's reshaping how we understand the land, the climate, and the future of technology. From buried villages and melting permafrost to quantum breakthroughs and deep earth energy, these discoveries aren't isolated events. They're connected pieces of a larger picture showing that change, scientific, environmental, and societal, is accelerating faster than expected. Canada has often been seen as vast and quiet, but beneath that surface, it's becoming one of the most dynamic frontiers of exploration on the planet. And as these findings continue to unfold, they're drawing attention from far beyond our borders. If even half of what scientists are seeing now holds up to further research, Canada could be standing at the center of major global conversations about history, climate, energy, and innovation. Thanks for following this journey through some of the most unexpected and important discoveries of 2025. If you found something here that surprised you or made you think, share it. Let others know that science isn't just something that happens in labs. It's happening right beneath our feet. Stay curious, stay informed, and keep an eye on what emerges next.